Hello friends, and welcome to a new session with edupediaworld.com, your favorite portal for online education. This session we shall take another method of finding the correlation coefficient, and that is the concurrent deviation method. Concurrent deviation method is another simple method of obtaining a quick but crude idea of correlation between two variables. Crude in the sense that it takes into consideration only the direction of change in the concerned variable and not the magnitude. Whether there is a change of 1 unit in the positive direction or there is a change of say 100 units, irrespective of the magnitude or the value of change, if the change is in the positive direction, it is considered as positive, and if it is in the negative direction, it's considered to be negative. Let's understand this by way of an example. Let's say we have a variable x and a variable y, and let's assume the values of x and y as say 25, 27, 30, 28, 33, 37, 35, 32, 31, and say 30. In the same way, let's say that the equivalent values of y are say 15, 18, 17, 16, 19, 22, 23, 21, 20, and 19. Okay. Now, whether in the concurrent deviation method, what is actually seen is whether there is a change from the previous one to the next one in the positive direction or in the negative direction. For example, if we see here, there is an increase of 2. I consider this to be positive. It's increasing in the positive direction by 2 units. Again, it's increasing in the positive direction by 3 units, but irrespective of how many units it's changing by, I just consider it to be a change in the positive direction. Further, when we see these two numbers, we see that the number has now changed in the negative direction. There is a decrease from this to this by 2 units, and that's considered as negative. Okay. Again, we see that there is an increase in the positive direction by 5 units. You see here the increase is by 2 units. Here it's increasing by 3 units. Here it's decreasing by 2 units. Here it's increasing by 5 units. It's plus 5. But irrespective of the value of increase or decrease, I consider it to be just positive or negative. Okay, so now let's see how to resolve this and how to proceed to get a value for the correlation coefficient. The direction of change in the concerned variables are noted by comparing the value by its preceding value. Okay, and if the value is greater than its preceding value, it's indicated by a positive sign, and if it is less, it's indicated by a negative sign. Further, if the values are equal, they are indicated by an equal sign. So let's do that in our example here. Let me draw 2 more columns to mark these change in the direction for both the x as well as for y. Okay, so let me call this as the deviation 1 and deviation 2 for x and y. So here we see, now for the first one we don't have anything to compare the first number with, so we leave it blank. The second number, we see that it's increasing in the positive direction. There is an increase, so I'll indicate this by a positive sign. Again, there is an increase, so I indicate by a positive sign. Now there is a decrease, so I indicate this by a negative sign. Here further we see that this is increasing, so it will be indicated by a positive sign. Next again there is an increase, so a positive sign. Decrease will be indicated by a negative sign. A decrease further will again be indicated by a negative sign. Here again negative, and again a negative sign. Okay. In case of y, the first number we see that it's increasing by 3 units, so a plus sign. It's decreasing this time, so a minus sign. Decreasing further, another minus sign. Increasing, so plus sign. Next from 19 to 22 we see there is an increase, so I'll indicate it by a positive sign. Further it's increasing, so I'll indicate it by a positive sign. It's decreasing, so it will be indicated by a negative sign here. Again decreasing and decreasing further. Okay, so we have marked the positives and negatives of both x and y. There was no number which was equal to its predecessor, so no equal sign was used. Proceeding further, all the pairs having same signs, that is, either both the deviations are positive or both are negative or both have equal signs, are known as concurrent deviations, and these are again indicated by a positive sign in a separate column which is designated as concurrences. Okay, so let's do that. We will have to make another column here, and that's named as concurrences, and we will have to see if for the row both the signs are positive or both are negative. In case if both are positive, I'm going to mark it with a positive sign. If both the signs are same, so the first one is left blank, here we see that both the signs are same, so I'll mark it as positive. Next, it's not same, I'll leave it for now. These two again, both are negative, but whether negative or positive, if they are same, I'm going to go ahead with a positive sign here in this column, in the column of concurrences. Okay, again we see that these two are marked by positive sign here, therefore again I'll mark this with a positive sign. Next two again are marked, we see that they have same signs, so I'll mark them by a positive sign. Further here we see that one is positive and another is negative, therefore I'll leave it for now. Next two we see are again negative, negative and negative, therefore we'll take all these three also and mark them as plus in this column. Okay, next, now these concurrences are denoted by C. Similarly, the remaining pairs having different signs are marked by a negative sign in another column, and we designate that column as disagreements. So we have another column called disagreements. Let me use a different color for that. Disagreements. Okay, and here we mark those which are having different signs. So when we see different signs, I'll mark this with a negative sign in the disagreement column. So I have one, and here I have the next one, so there are two. Okay, is that clear? Yeah. So let me just repeat the steps. What you do is you take your values of x and your values of y separately and check the values of x and y individually from the predecessors. Let's start with x. In the x, I first check my values between these two and see if it is increasing or decreasing. If the value increases from its predecessor, if it is more than its predecessor, we mark it with a plus sign. If it is less than its predecessor, we mark it with a minus sign. Okay, and the same with y. So once I have marked all the values of x and y with my plus and minus signs, I'll form two more columns, one for concurrences and another for disagreements. Okay, concurrences is denoted by the letter C. Now if both for x as well as y, that is if your deviation of x or the deviation of y, if both of these have the same sign, whether positive or negative, I'll mark the concurrence column with a positive sign. If they have a different sign, I'll not do anything here, but in the disagreement column I'll mark that with a negative sign. So a difference in sign is indicated by disagreements with a negative sign in the disagreement column here. Okay, next, the coefficient of correlation is denoted by RC and is given by the following formula. RC equals plus or minus root under plus or minus 2C minus D divided by D. Now we know that C is the concurrences, number of concurrences, and D is the number of pairs of observations. Okay, so C is the total number of concurrences, that's here. The total number of concurrences here, C is given by, let's count and see, 1 2 3 4 5 6 7. So we have 7 as C, and the formula, let me write the formula now, is equal to plus or minus root under, again plus or minus 2C minus D divided by D. Now we have plus or minus both inside the root as well as outside. I'll explain this in a while. So we have got the value of C here. Now what is D? D is your number of pairs of the values which we have here. So number of pairs, if we see, is equal to 1 2 3 4 5 6 7 8 9. So there are two ways in which you can find. See, the total number of values we have here is equal to 10, and D will always be equal to n minus 1. So that's one way. So D is equal to n minus 1, which is equal to 9 here, 10 minus 1. Another thing is you can count the number of pairs of the signs which you have marked, 1 2 3 4 5 6 7 8 and 9. Or the third way is that it is the sum of the concurrences and disagreements. We see that there are two disagreements, so it's 7 plus 2 is again equal to 9. So your D is equal to 9. Is that clear? Okay, so now coming to the formula, what we will do here is, first we will take this part alone and solve it. So it's 2C minus D divided by D. Okay, and the value is equal to 2 times C, which is 7, minus D, which is 9, divided by 9. So it's 7 into 2 is 14, minus 9 divided by 9, and that is equal to 5 by 9. Now we see that this is positive, right? This is positive. So once it is positive, I'll take that even outside the root, and then of course I'll find the root of this value. Okay, had it been negative, let's assume that the value of RC is negative, something like this. Say you have RC equals the value of 2C minus D by D. Let's say that the value we got for this is negative. Okay, say it's coming out to be minus, say, 1 by 2. In that case, our formula is of RC is plus or minus root under plus or minus 2C minus D by D. Okay, if this happens to be negative, I'll of course take the negative one. Okay, and the entire value of RC will be actually negative. But for the purpose of taking the square root, we will take away the sign from here and bring it down outside the square root. The reason, if we take the root of a negative number, we will get an imaginary number, right? Therefore we will take the root of only this part, and that is why we have both the signs given outside as well as inside the square root here. Okay, so whatever sign you get here for this value, the same is taken for RC. Okay, but while taking the root, we do not consider the sign. Is that clear? So do not consider the sign while taking the root, but whatever sign you get in the calculation of 2C minus D is the actual sign which is to be taken here outside, and that will be the value of RC. So that will determine whether your correlation is positive or negative. Okay, so in this case our correlation value RC is positive, and the value is equal to the square root of 5/9. Okay, so this is our formula. Then proceeding further, there are certain things to note which I've already explained to you. Let me just read it once for you. The sine of RC is taken to be equal to the sine of 2C minus D by D. Okay, and when 2C minus D by D is negative, we make it positive for the purpose of taking its square root. However, the computed value will have a negative sign, and the sine of RC will be positive when 2C minus D by D is positive, and it will be negative when the value 2C minus D by D is negative. Okay, so now let's take some numerical problem and understand the working. So here we have the marks of 11 students in economics and in statistics. So let's do this. You already know the working. You can pause me for a while and do this yourself. Then I'll work it out for you and you can check your answer. Alright, so here we go. Let's assume that the marks in economics are denoted by X and the marks in statistics by Y. So now we have D, the deviation for X, and D for Y. Okay, now looking at the values of X first, we start with the first pair, that is the first and the second number, and we see that the second number is less than the first one, so there is a reduction in the value. It's going in the negative direction, therefore I'll mark this with a negative sign. Okay, and then we see that it's increasing this time from 45 to 55, so here the second value will be marked by a positive sign. Further, again there is an increase, although just by 1 unit, but still it's to be considered as an increase, and an increase by 1 unit, therefore I'll mark it by a positive sign here. Next, again there is an increase, therefore another positive sign here. Further, again there is an increase of 2 units, so another positive sign here. Again we have from 60 to 65, this is to be marked by a positive sign. Next, again increasing to 68, another positive sign. Next to 70, we have another positive sign. 75, that will also have a positive sign, and finally 85 will have another positive sign. So we see that except the first one, we see all other values have a increasing trend. Similarly, coming to the column Y, let's analyze the values here. Again we see that the first two pairs, the first and the second number, we see that the second number decreases from first, therefore it will be marked by a negative sign here. Going further, we have, again we see that it's decreasing further from 56 to 50, so another negative sign here. Next, it's again decreasing, so we'll have another negative sign here, but now there is an increase, therefore we will mark it with a positive sign. Next, again it's increasing though, so another positive sign here. Increase, so it will be marked with a positive sign. Again it's increasing, so mark it with a positive sign. Okay, again there is an increase, so mark it with a positive sign. From 70 to 74, again there is an increase, so a positive sign here. And finally the last one, also we will have a positive sign. Okay, so once you have marked the deviations of both X and Y, I need to check the concurrences. The concurrences in the next column, and the disagreements. So first pair we see, let me mark the concurrences with say one color and disagreements with another. So you have concurrences here, you have again these two are positive. We see that these two are not, one is positive, another is negative, so these two are in disagreement, whereas the remaining all others we see are in agreement. So they are marked as the row with concurrences, and let me use a color here for this, okay, and mark all of these with a positive sign. Okay, and the remaining ones, these two are in disagreement, so let's mark these with a different color, and let's say that these are in disagreements. Okay, and here these are to be denoted by negative sign, these two. Okay, so now counting the number, we have total number of concurrences, as we can count it as with the function here. Well, so it's not taking into consideration the sign. Never mind, we can just count it manually, and we see that there are totally 1 2 3 4 5 6 7 8 positive signs. So the total number of concurrence is 8, and the total number of disagreements are just 2. So 2 disagreements and 8 agreements or concurrences. Okay, so this is actually now my value of C. So C is equal to 8, and what about my D? D will be equal to 8 plus 2, right? So D will be equal to the sum of these two, or either you can take it this way, or you can also take it as n minus 1. So my n we see here is, total number is 11, so it will be 11 minus 1, which is 10, or the number of pairs which we have here. So 1 2 3 4 5 6 7 8 9 and 10. So either way, our D is equal to 10. Next, I need to calculate the value of 2C minus D divided by D. So let's do that here. We have 2 multiplied by the value of C, which is 8, 2C minus the value of D, which is 10, 2C minus D divided by D, which is again 10, and that's equal to 0.6. Okay, now this is positive, therefore my correlation value is going to be positive, and the value of correlation RC is the square root of this number, square root of this number. Okay, so my value of correlation coefficient using the concurrent deviation method for this is 0.77. Okay, now the sign of this is positive, the sign of this is taken from here. If this is positive, the value will be positive. If this value is negative, the value here will also be negative, but for the purpose of taking the square root, we will ignore the sign of this, we will just take the number and take the square root. So that point should be clear, and you must remember this point while solving a problem. Alright, so that was the practice of a numerical problem, and let's see where this is suitable. This method could be used. This method is suitable only for the study of short-term fluctuations, and the reason is obvious. It's so because it does not take into account the changes in the magnitude of the values which we have already seen. Okay, it gives same weights to smaller as well as to larger deviations, and that's why it's not suitable for any and every question. But if the fluctuation is normal, if it is minor, maybe fluctuation varying from 2 to 3 or 4 units in both the directions, we can very well use this method for its simplicity. Okay, if the fluctuations are very high, then obviously it will not give you answer closer to the actual answer. Okay, even now of course it doesn't give you an answer equal to that of the Karl Pearson's coefficient of correlation or the Spearman's rank correlation, but it gives an idea whether the correlation is positive or negative, and if and what the magnitude of the correlation is, if it is moderate, very high, or very low. Well, so that's all we have in this session. For more topics under statistics, keep watching Edupedia World videos. Thank you.